Now again, let's continue these videos on the dying arts of plumbing, gas and central heating. And in today's video what we're going to look at is every gas engineer's favourite when they come in for reassessment, ventilation. So let's get on with it and find out exactly when and where we need ventilation and how we work it out. Now, there is no boiler on the UK market that requires ventilation. Whether it's a heat only boiler, whether it's a system boiler or whether it's a combi boiler, they do not require purpose provided ventilation for combustion. Because they're room sealed, they get their air for combustion from outside. So no boiler in the UK market requires ventilation. And that is if it's installed in a room, a cupboard or a compartment, because they also don't need ventilation for cooling purposes like the old cast iron heat exchanger boilers required in the old days. So no boiler in the UK market requires purpose provided ventilation for combustion or cooling in a domestic situation. So why do we still do ventilation in our ACS reassessment? Well, some fires still need ventilation, some cookers still need ventilation, and we've also got Flueless space heaters what require ventilation. So that's what we're going to be looking at in this video on all the appliances what require ventilation. But first of all, we're going to be looking at this old floor standing open flued cast iron heat exchanger high water content boiler installed in a room. Now we've got an outside and an outside here, and number one is where the vent is bringing the air in for combustion. Now this boiler here is a 30 kilowatt gross boiler. So first of all what we need to do is we need to turn it to the net figure, because since the year 2000 we've used the net figure for ventilation, not the gross figure. So 30 divided by 1.11 comes out at 27.02. Then we can minus 7. Now, we can minus 7 for adventitious air, and that is the air that naturally occurs in a building. So it comes in via windows, doors, through floors. But since 2008, we have not been able to use adventitious air in a new build or a house what has been renovated to the standards of a new build since 2008. Anyway, this is pre-2008, so we can minus a 7 for adventitious air. Once we minus a 7, it comes out at 20.02. Then we need to take that figure and times it by 5, because we need 5 centimetres squared per kilowatt over 7 to give us our free air. So 20.02 times 5 comes out at 100.13 centimetres squared. So 101 centimetres squared. So that's what free air we would need to give here at the air vent to allow this boiler to work safely and efficiently. Now, what if instead of just being one room, we now have 2 rooms where we've got to get the vent from here through into here. So we've now got 2 rooms. Now our internal vent must be installed low down, and it must be no more than 450 millimeters from the floor to the top of the vent. And that is so smoke in a fire doesn't spread through the rooms, because if that vent was up there, then the smoke would be able to go up and across. This is where the fresh air comes in. So the air for combustion would come in and go through there. So what size does that vent need to be? Well, that vent there would be exactly the same size as this vent here. So vent number 1 would be 100.13, and so would this vent would also be 100.13. It only changes if we add another room. So now we've added another room. So we've now got 3 rooms. So we've got 2 vents now communicating with the outside vent. So the air for combustion for this open flue boiler is now going via 2 rooms. Again, this vent cannot be more than 450 mil off the floor. So what happens to sizing the vents now? Well, now we have to change vents 2 and 3 to be 50% larger than vent number 1. So the way I do it, because my maths isn't that bloody good, what I do is I take the 100.3 from vent number 1, because it's got to be 50% bigger, then I divide it by 2, which gives me 50.065. Then I need to add on the 100 back on, so well, the 100.13 back on gives me a total of 150.195 centimetres squared. So 151 centimetres squared for both 2 and 3, because they need to be 50% larger than vent number 1. Now I've put this boiler into a compartment. So we've got room, 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 compartment. So we've still got our air communicating from this side of the property. So the air for combustion will need to go through these 3 vents first and then through into vent number 4. Now the path of the combustion air comes in here, goes through these vents, into this vent and goes into the boiler for combustion. It also goes into the draft diverter for diluting the products of combustion, and the top vent is for cooling. So that's why we need 2 vents in the compartment. So the bottom one supplies the combustion air and the top one supplies the cooling. So what size do these vents need to be? So let's take number 4 first, which is our low level or bottom vent. So we have 27.02 kilowatts, because remember we need the net kilowatts, not the gross one. But this time we're not minusing any 7. So we do not knock off advantageous air for vents that are supplying compartments or cupboards. So we have 27.02 times 20. And that comes out at 540.4 centimetres squared for the bottom one. Now the bottom vent is always twice the size of the top vent. So the top vent will be, again, 27.02, because remember that is the net kilowatts of this boiler, times 10 equals 270.2 centimetres squared. So if we have a boiler in a compartment communicating with 3 rooms, we will need 5 vents for that. 1 from outside, 2 going through the rooms, and then 2 from the compartment. But what if the vents communicate direct to outside and we don't need all of these? Now we've got our 2 vents communicating direct to outside now to this compartment. So forget any of these vents now, they're not needed. So instead of going through all the rooms, we're just coming direct from outside. Now our low and high vents are still required. And our bottom vent this time cannot be lower than 300 mil off the floor. And that's because of we don't want any snow, rain or debris getting in and blocking the vent. Now the bottom one again supplies the air for combustion and diluting the products of combustion, and the top vent is then there for cooling the compartment. But this time we're going to times them by a different number. So if we take vent number 6 at the bottom, again we take our net kilowatts. Remember it was a 30 kilowatt gross boiler. we've now turned it to net 27.02. This time we're going to times it by 10, which is 270.2 centimetres squared. Then the top vent needs to be half the size, so it'll be 27.02 times 5 is 135.1 centimetres squared. So that is if the air is coming direct from outside into the compartment for combustion. Now the last thing with a compartment is the position of the vents. As well as having them high and low, we couldn't do this with the vents. So a vent at the bottom here and one directly across from the bottom here. We can't first of all take air from different places. They've got to communicate from the same way. So if we did do this, the air from outside would go straight through, straight into the room and not give us our air for combustion. This is called cross ventilation and this is not allowed. This would also be deemed as at risk in an unsafe situation. So they have to be on the same wall, high and low, communicating from the same direction. So that's our look at this boiler. Let's have a look at some specialist ventilation for other appliances. Now let's have a little bit of a game or a bit of a quiz and fill in some blanks in these questions to help you along with learning ventilation. So shout out if you know the answer. So number 1. An inset live fuel effect fire of 6.9 kilowatts net is installed in a living room. So what ventilation would that require? Well, the answer is 0 centimetres squared because it's less than 7 kilowatts. So a gas appliance under 7 kilowatts normally doesn't require ventilation unless the manufacturer's instruction states otherwise. Did you get it? Anyway, let's try number 2. So now we've got 2 inset live fuel effect gas fires of 6.9 kilowatts in the same room, which used to be 2 separate rooms which has been knocked through, or what we call a through room. So we've got now 2 inset live fuel effect fires in the same room. Well, the answer is 0 centimetres squared. Because basically what they say is the rooms were big enough to take the 6.9 kilowatts in the first place. So as long as they are not affected on spillage, then we can leave them as they are. So the first thing you would do is test them for spillage individually. So you'd have one running and one off and test them both. If they both pass, then you would put them both on at the same time. And then test again to see whether they pass. So as long as they are not affected on the spillage test, we can leave them with no ventilation. Number 3. A DFE fire of 19 kilowatts net is installed in a living room. What ventilation does that require? 100 centimetres squared, did I hear you say? Well, if you did, you would be bang on. A DFE in a living room would require 100 centimetres squared of free air as a standard, unless the manufacturer says otherwise. Number 4. Now we've done the same thing as the inset live fuel effects. We've got a through room, so we've now got 2 DFEs technically in the same room, which used to be a 2 separate rooms, so it's now a through room. So we've got 2 DFE fires of 19 kilowatt net in the same room. 200, did you say? Well, you'd be wrong, because it is 235 centimetres squared. Because each fire would require 100 centimetres squared, and then you can only add adventitious air for one gas appliance in the same room. So because the 100 is a standard, we have to add on adventitious air, which is 35. So 7 times 5, 35. So it becomes 235 centimetres squared. Did you get that one? Good if you did. Number 5. So we've got an insect live fuel effect fire of 6.9 kilowatts net and a solid fuel stove in the same room. So what ventilation would we require for that? Because anything less than 7 kilowatts does not require ventilation. So did you say 100 centimetres squared? Well, if you did, you'd be correct. Now the reason for this is because we've got two different fuels. So even though the insect live fuel effect fire doesn't require any ventilation, it just requires the advantageous ventilation, and the solid fuel might not even need ventilation, but because we've got two different fuel types, both open fluid appliances, we need to add on 100 centimetres squared of free air. So let's have a look at this last one, number 6. So we've got an open fluid boiler of 24 kilowatts net and a cooker in a room of 9 meters cubed. So these two appliances are installed in the same kitchen. So let's have a look at the boiler first. So the boiler is 24 kilowatts net, so it would be 24 minus 7 times 5 is 85 centimetres squared. And the cooker, so a cooker in a room between 0 and 5 meters cubed needs 100 centimetres squared, and an openable window. A cooker between 5 and 10 without a back door, direct to outside, just a window, would require 50 centimetres squared. Doesn't mention a door, so 50 centimetres squared. So what's the answer? Well, did you add them together? Or did you say the answer was 85 centimetres squared plus an opening window? Then you would be correct. Now the reason it is 85 centimetres squared plus the openable window is if the boiler was working on its own, we've got 85 centimetres squared of free air, we've got enough ventilation. If the cooker's working on its own and we've got 85 centimetres squared, well, we need 50 for the cooker, so then that would be okay. But what they say when they're both running, because this appliance is an open fluid boiler, it has a draft diverter. So if the room becomes vitiated, the boiler will actually draw that vitiated air up the draft diverter and help bring in clean air through the vent. So that's why we don't need to add the two together, we just need to take the largest one, because the appliances themselves will help get rid of any vitiated air. Vitiated means lack of oxygen. So, how did you do? Put down in the comments, guys, and tell me, did you get 6 out of 6? Let me know. Now, this next scenario is probably the one where most of the engineers on reassessment just look at me when I do any training with them and I ask them about Flueless space heaters, and they just look at me as if I've got a square head. Anyway, let's go through Flueless space heaters, and virtually every gas engineer I ask on reassessment, have you fitted any Flueless space heaters, they always say no. So this is like hen's teeth, very, very rare, I believe. So anyway, we have a scenario. We have a Flueless space heater of 3.7 kilowatts net in a room of 90 meters cubed. So first of all, what do we mean by a Flueless space heater? Well, basically it's a fire in a living room and it's not connected to a flue system. It means the products of combustion come into the room and it uses a catalytic converter to convert the CO into CO2. So we require permanent ventilation for a Flueless space heater. So this is how we work out whether one it can actually fit into that room, and two, what size ventilation we actually require. So the first thing is, let's see if a 3.7 kilowatt net Flueless space heater can go in a living room of 90 meters cubed. Now, according to the standards, a Flueless space heater in a living room comes under what's called 45 watts per meters cubed. That means we are allowed 45 watts per meters cubed of that room. So let's look at that. So 45 times 90 equals 4050 watts. Now, how many watts are there in a kilowatt? 1,000, well done. So we do 4050 divided by 1,000 equals 4.05 kilowatts. So we have a 3.7 kilowatt fire, and the room can take 4.05 kilowatts. So can that fire go in that room? Well, hopefully you've said yes, it can, because the room can take more than the fire itself. So that's the first thing we've done. Now, if the room was too small for this fire, then it would be deemed as at risk. But if it failed its flue gas analyzer readings, the Flueless space heater, then it would be ID. So we know the room's big enough. So the next one we need to do is work out what size vent we require. So basically, what it says in the standard is a fire up to 2.7 kilowatts net, a Flueless one, installed in a room can have 100 centimeters squared up to 2.7 kilowatts. Then for every kilowatt over 2.7, it requires an additional 55 centimeters squared per kilowatt. So we've got a 3.7 kilowatt fire. So 3.7 minus 2.7, because that's what we're allowed up to 100 centimeters squared, equals 1 kilowatt. 1 kilowatt difference. So we need to take that 1 kilowatt and times it by 55, because we need an additional 55 centimeters squared for every kilowatt over 2.7. So that equals 55. But then we need to add on the 100 plus 100 gives us a total of 155 centimeters squared of free air. Now, also a Flueless space heater needs this vent to be at least 1 meter away from the appliance, and that is to stop the ASD, keeping the fire working if anything happens and vitiates, so the safety device will knock off if the room vitiates, so it needs to be more than 1 meter away. Also, all Flueless appliances require an openable window, and a Flueless space heater requires a primary source of heat. And a lot of people miss that out. So you cannot have a Flueless space heater as your sole primary heat source, because they're not designed to run like that. So you would need radiators in there, and the Flueless space heater would just be your focal point or your background heating, not your primary source. So that is the ventilation for Flueless space heaters. Now, just to finish off this video on ventilation, another problem I see a lot of in trading, especially guys coming in for reassessment, is how do you actually size an air vent for gas? Dead straightforward process, but because again it's not done on a regular basis out there in the field because of lack of open fluid or appliances what require ventilation, most engineers seem to forget what they've got to do. It's quite easy. So the first thing we need to do is we need to measure using a steel rule inside the air vent, and we actually measure it from inside the hole. So the hole itself, none of the frame measurements. So the inside of this air vent is 95 millimeters. And the next thing we need to do is we need to place the actual steel rule on the same angle as the vent, because these are deflected, so it stops air going straight the way through it. So if I go on to that one there, flick it over and measure that there, that is coming out at 5mm. So 95mm long, 5mm in depth. Now an air vent cannot be smaller than 5mm and cannot be larger than 10mm. That's to stop insects and rodents getting in. So for this vent, I've got those measurements, and then I need to times it by how many there are. So there's 1, 2, 3, 4, so there's 8 altogether. So it would be 9.5 times by 0.5 by 8 will give me my centimetre squared for this vent. So if we put these figures on the board, so 9.5, remember it's 95mm, so I've turned that to centimetres because our final answer needs to be in centimetres squared. So it's 9.5 centimetres times 0.5 centimetres equals 4.75 centimetres times 8 comes out at 38 centimetres squared. So that's how you would size a vent. Now obviously vents which are closable, vents with fly screens are not allowed to be used on gas appliances. Also vents which are made of aluminium are also now deemed the incorrect type, because if you punched it, it would flatten it and close it, so it wouldn't be any good. But if you punched a plastic one, it would break, so then you get a bigger hole, so it's not unsafe. Anyway, another one is the terracotta bricks, which aren't allowed now. So in the old days when I was apprentice, we used to have one at the front, one at the back, and we bridged it with slate in the cavity so the air would pass all the way through. Biggest problem with these is that's what you would see, but the holes are tapered and smaller at the back, so you would have to measure the back ones. So they brought out these special devices where you could put in there and test them. Now the size of these holes are obviously can't be more than 10mm. So a bit of a cheat what you could do nowadays if you didn't have one of the gauges is you could get yourself a 10mm drill, and if it doesn't go through the hole then you know it's 9mm like it should be. But you have to measure the back of these, not the front. So these are now also classed as not good enough for gas vents. But like I say, if they are in and they're bridged, and you can check that they're less than 10mm, then they can be deemed okay. So that's my look at ventilation. Hopefully you've liked the video, and I'll catch you on the next one. Cheers.